Welcome to my presentation on transportation problems. In today's lecture, I will examine the various methods of solving transportation problems. I will also provide work examples to illustrate the various methods. Please watch the lecture to the end for better understanding. So, what do you mean by transportation? Transportation model is a special class of linear programming that aim at minimizing the cost of transporting goods from the various sources. A special class of linear programming that aim at minimizing the total cost of transporting goods from their various sources. There are several methods of solving transportation problems. I will examine the northwest corner rule, the least cost method, and the Vogel approximation method in this lecture. So, I've told you that transportation problem, I said it's a special class of linear programming that aim at minimizing the total cost of transporting goods from their various sources. So we have balanced transportation problems. Balanced transportation. So a transportation problem is said to be balanced where the demand equals the supply. Where demand, the total quantity demanded, equals to the total quantity supplied. So that is, it's when the total quantity demanded by the destination equals to the total available at the origin. Now, examples of balanced transportation problem. Suppose you have destination. Maybe you have 4 different destinations. 1, 2, 3, and 4. Then you have origin. Origin, you have A, B, and C. Then you have the supply, and you also have the demand. So, maybe you have different costs of transportation. Maybe at the destination number 1, maybe you incur 2 naira, this one 5 naira, this one 3 naira. Here you have 4 naira, 2 naira, 1 naira. Here you have 6 naira, 3 naira, 4 naira. And here you have 5 naira, 6 naira, and 7 naira. Suppose these are the costs of transporting the product through the various destinations. Then supply. So here maybe 20 units were supplied. Here maybe you have 40. Here you have 10. If you add it together, you have 20 plus 40, that is 60, plus 10, that is 70. Suppose you have 20, 30, 5. This is 20 plus 30, that is 50. Plus 5, that is 55. Then if this is 15, 55 plus 15, that is 70. Then, and this is equal to 17 as well. So that means the demand here is 70 and the supply is also 70. That kind of problem is said to be balanced. So this transportation problem is said to be balanced. That is balanced transportation. We also have the unbalanced transportation problem, where demand and supply are not equal. We have unbalanced transportation problem. I said the transportation problem are said to be unbalanced, where the demand and supply are not equal. Unbalanced transportation. Demand may be less than supply. Demand may be greater than supply, or demand may be less than supply for an unbalanced transportation problem. Let's use the same illustration. except that you have this to be 20 instead of 30. If you have 20 plus 20, that is 40, plus 5, that is 45, plus 15, that is 60. So this one is 60. Why 20 plus 40, that is 60 plus 10, 70. You can see supply equal to 70, while demand equal to 60. So this transportation problem is said to be unbalanced. I want you to know that where demand and supply are not equal, where demand and supply are not equal, there is a need to create a dummy to equate the demand and supply with zero cost. You create a dummy to equate the demand to the supply, but the cost of that dummy activity will be zeros. Now, this is what I mean. So, we want to balance this transportation problem. So, you have destination 1, 2, 3, and 4. Then, you have origin A, B, and C. We have supply, and we also have demand. But before I create that, before I introduce that, now here you have 2, 5, 3, 2, 5, 3. Here you have 4, 2, 1, 4, 2, 1. Here you have 6, 3, 4, 6, 3, 4. Here you have 5, 6, 7, 5, 6, 7. Here you have 20 as our supply. Here you have 40. Here you have 10. Demand is, here we have demand. Our demand we have 20, 20, 5. Then we also have 15. But we want this to be totaled 17 as well, so that our demand and supply will be equal. So you need to introduce another 10 here. Let me extend this column. So 20 plus 20, that is 40, plus 5, that is 45, plus 15, that is 60. Then we are left with 10. So we introduce 10 here to make it equal to 70. So this column will now be supply column, while this will be the dummy activity. So dummy. I've told you that the cost of dummy activity should be taken to be 0. The cost of dummy, you take it to be 0. So we have 0, 0, and 0. So our supply, we have 20, 40, and 10. So if you sum it up, 20 plus 20, that is 20 plus 40, that is 60, plus 10, that is 70. If you now have 20 plus 20, 40, plus 5, that is 45, plus 15, that is 60, plus 10, that is 70. So you can introduce dummy to the supply column, you can introduce it to the demand column, depend on the way the problem is structured. That is for unbalanced transportation problem. Methods of solving transportation problems. I'm going to categorize the methods of solving transportation problems into 2. Number 1, we have method of obtaining the initial solution. Under this method, we have north, west, corner rule. North, west, corner rule. We have least cost method. Number 3, we have Vogel approximation. method. These are methods of obtaining the initial feasible solution. Number 2 method is the method of obtaining the optimal solution. Method of obtaining the optimal solution. I've told you that the first method or methods are the methods of obtaining the initial solution, while the second category are the method or methods of obtaining the optimal solution. So methods of obtaining the optimal solution include, number 1, we have stepping stone method. Stepping stone method, SSM. Number 2, we have modified distribution method. Modified distribution method, which is MODI, M-O-D-I. Now, I'm starting with the method of obtaining or methods of obtaining the initial solution. For this method to be used, that is the method of obtaining the initial solution. For this method to be used, it must satisfy the following conditions. What are the conditions for using any of these 3 methods? That is, method of obtaining the initial solution. Number 1, the problem must be balanced. The problem must be balanced. I've told you that a balanced transportation problem is the transportation problem in which the quantity demanded equal to the quantity supplied. Demand and supplied are equal. Number 2, the number of cell allocation. Number 2, the number of cell allocation must be equal to m plus n minus 1. The number of cell allocation must be equal to m plus n minus 1. When the above conditions are satisfied, we say the solution are non-degenerate. So when these 2 conditions, when they are satisfied, we say the solution are non-degenerate. But if these conditions are not satisfied, we say the solutions are degenerate. So now your M is the row, N is the columns. That is, the number of cells you are going to allocate to must be, if you sum up the row and column, maybe you have 4 rows, you have 3 rows and 4 columns. 3 rows and 4 columns. 3 rows, 4 columns. If you sum it up, that is 7. By the time you now subtract 1 from 7, that means the number of cells you are going to allocate to must be 6. If you have 3 rows and 2 columns, that means 3 plus 2, that is 5. That means 5 minus 1, 4. So the number of cells you must allocate to must be 2 plus 3, which is 5, minus 1, must be 4. So take note of that. That is where the row equal to 2 and column is 3. 2 plus 3, 5 minus 1, 4. So take note of that. So I've told you that where these conditions are satisfied, we say the solution are non-degenerate. Degenerate. But where these conditions are not satisfied, we say the solutions are degenerate. Please take note of that. I want to start with the northwest corner rule. Northwest corner rule. Northwest corner rule. This method is the simplest but most inefficient method, as it always has the highest total cost of transportation when compared with other methods. So I've told you that the northwest corner rule, I said, is the simplest method, and that method is the most inefficient method when you compare it with other methods of obtaining the total cost of transportation, method like the least cost method and Vogel approximation method. Steps for solving transportation problem using northwest corner rule. Step number 1. Begin by allocating to the top left hand cell. Step 1. Begin by allocating to the top left hand cell. So that is, you start from the northwest corner. Step 2. Exhaust the supply at each row before moving to the next row. Exhaust. That is, you have to make sure that the whole of the supply at each row is exhausted before moving to the next row. Exhaust the supply at each row before moving to the next row. Step 3. Utilize the demand of each column before moving to the next right column. Utilize the demand of each column before moving to the next right column. Step number 4. Check to see that all supply and demand are met. Check to see that all supply and demand are met. These are the steps for solving transportation problems using the northwest corner rule. Example: SAO company has 3 plants or locations A, B, C, where its goods can be produced with production capacity of 50, 60 and 50 per month respectively for a particular product. These units are to be distributed to 4 points X, Y, W, Z of consumption with the demand of 50, 70, 30 and 10 per month respectively. The following table gives the transportation cost in naira from various plants to the various points of consumption. They are given destination, they are given sources of plant, destination X, Y, W and Z. They are given A, B, C as the plants. You are to obtain the initial basic feasible solution by northwest corner rule. So NWCR. So now let's have the solution. So we have destination, destination. We also have destination X, Y, W, and Z. We have plants. Plants A, B, C. What are the costs of each plants or destinations? Now, you have we have 21, 19, and 24. 21, 19, and 24. Then for Y, we have 18, 18, and 25. 18, 18, and 25. For W, we have 24 and 27, 24, and 28. 27, 24, and 28. For Z, we have 22, 20, and 25. 22, 20, and 25. Now, you were told SO company has 3 plants or locations A, B, C where its goods can be produced with production capacity of 50, 60, 50 per month respectively. Capacity, that is talking about the supply per month. So we have, that is for A, B, C. The capacity is 50, 16, and 50. Capacity A, this is A. We have 50. Capacity B, 60. And for C, we have 50 as well. That is supply. Then, back to the question. These units are to be distributed to 4 points, X, Y, W, Z, of consumption with the demand of 50, 70, 10, and 13 and 10. So we have demand 50, 70, 30, and 10. That is for the demand. The first step is to check if the transportation problem is balanced. So that is, if the demand equates supply. 50 plus 60, that is 110, plus 50, that is 160. So we have 160. Then 50 plus 70, that is 120, plus 30, that is 150, plus 10, that is 160. So in this case, demand equal the supply. I will still give another example where demand and supply will not be equal. So this type of transportation problem, we call it a balanced transportation problem. That is where demand and supply are equal. Now, you want to solve the problem using the northwest corner rule. So you start with from the top left-hand cell. So under the northwest corner rule, you start your allocation from the top left-hand cell. Now, here we have the first cell is 21. So you make your maximum allocation to this. Here you have supply to be 50, then demand 50. That means you can allocate the 50 to this. So if you allocate 50 here, that means you have allocated the 50s. So you are left with 0. Then in this column, since 50 have been allocated to this column, you'll be left with 0. So this is exhausted. Now you move to the next one. You can't allocate anything to this row again and this column again, since you have utilized the maximum of 50 you have in this column. Since the 50 you have in this column have been allocated, have been utilized, there is nothing left. So nothing can be allocated to this column again. Now, this roll again, nothing can be allocated there since you have exhausted the 50 you have in this row. We move to the next one. Since we can't allocate to this, so you can't consider this. So you consider allocating to this. So in this row we have 70, and we have 60. This column we have 70. That means what you can allocate must not exceed what you have here. So you allocate 60 to this. Then this 60 is exhausted, so you have 0. Then you have allocated 60 from 70. You'll be left with 10. Then the remaining 10, remember we can't allocate to this since you have exhausted what you have here. So we consider allocating the remaining 10 to this. So 10 to this, then the 10 is exhausted, you have a 0. Then this row, you have allocated 10. 10, you'll be left with 40. Now, you can't make any further allocation to this row. And you can't make any further allocation to this row as well. No allocation can be made to this column, and no allocation can be made to this column as well. So we consider this. Since you can't allocate to these two rows, so you consider this now. And what you have here is 30. So you can allocate 30 to this. So the 30 is exhausted. You have is 0. Then from the 40 you have left here, you've allocated 30. So you'll be left with 10. Now, the remaining 10, you can as well allocate it to this. 10, then this is exhausted. Then the 10 here, you have exhausted. So, that is allocation table. Now, what will now be the total cost of transportation? Total cost of transportation using northwest corner rule. So, we have 21 times 50. 21 amount is in naira. 21 times 50. So that gives us 21 times 50. You have 1,050 naira. Then here we have 18 times 60. 18 times 60. 18 times 60. That gives us 1,080. Then here you have 25 times 10. 25 times 10. So that gives us 250. 25 times 10, 250. Here you have 28 times 30. 28 times 30. 28 times 30. That gives us 840. Here you have 25 times 10. 25 times 10. So that gives us 250. Remember, you have allocated the whole 160 you have, so you can cross it out. Nothing remains. So, what is the total cost of transportation using the northwest corner rule? So, you have 1,050 plus 1,080 plus 250 plus 840 plus 250. So we have 3,470. 3,470 naira. So that is the solution to the question. So this is the end of the part 1 of my presentation on transportation problems. So the next part, I will examine the least cost method as well as unbalanced transportation problem. I will solve questions involving unbalanced transportation problems. Thanks for watching Ezeka.